Alrighty, ladies and gents, in this video we're going to go over how to calculate future value and present value of a continuous income stream. Okay, so first of all, what's an income stream? An income stream means that instead of depositing money just one time throughout the entire life of the investment, is you're continually pumping money into this account. This is why we have to use calculus as opposed to in algebra where you were able to use the PERT formula. I don't know if you guys remember that. But anyways, before I can get into future value and present value of income streams, I need to go over how do we integrate the exponential function e. Okay, so let's focus on that for a few minutes here. So specifically what I'm saying is the integral of e to the u. So I'm going to use my u substitution notation here. The integral of e to the u du is still e to the u plus c. Why is that the case? Because if you guys recall, the integral of e to the x, or excuse me, the derivative of e to the x was still e to the x. So remember, the power doesn't change when we take the derivative of e, so that's why the power doesn't change when we integrate e. Okay, so for example here, let's use some u substitution here. For example, let's say we wanted to integrate from 0 to 3 e to the, let's say, negative 0.5 t dt. Okay, so this is similar to the intervals you'll be seeing in this section. All right, so we're going to use u substitution here. So if it's an e to the u issue, we're going to let u equal just the exponent. So u is going to be a negative 0.5 t, right? And then du is going to be, well, the derivative of negative 0.5 t, which is a negative 0.5 dt this time, because we took the derivative with respect to t. But we notice in our integral we only have a understood 1 dt. So hopefully you guys now know the pattern from previous videos, but we're going to take the fraction that we need to multiply both sides of our du equation by is 1 divided by a negative 0.5. Okay, remember you take the coefficient of the differential in your integral, you divide it by the coefficient in your work. Okay, that multiplies a negative 0.5 dt. All right, if you go to your calculator, 1 divided by a negative 1/2 is going to be a negative 2. All right, so to see that, I take 1 divided by negative 0.5. It's going to be a negative 2. All right, so we have basically a negative 2 du is going to equal a positive 1 dt. So that's what we need, right? So now let's perform our substitution. Okay, so now we perform our substitution. So I'm going to drop my bounds for now. Go back to the definite integral video on substitution for the explanation on why you drop your bounds. But this will be e to the u, right? I replace negative 0.5 t with u. And then the 1 dt, now that subs out, and that becomes a negative 2 du. All right? Okay. So now we integrate, and remember the integral of e to the u is still e to the u. So when we integrate a negative 2 times e to the u, we're going to get the exact same thing, negative 2 e to the u. All right, technically there's a plus c, but since it's a definite integral, the c will drop off. And now let's bring back u in terms of t. So u was a negative 0.5 t. So this is a negative 2 e to the negative 0.5 t plus c. Okay, and we're going to evaluate this from, now we can bring back our t bounds. Our t went from 0 to 3. All right. Now we're going to plug in 3 for t first. So that gives us a negative 2 e to the negative 0.5 times 3 minus a negative 2 times e to the negative 0.5 times 0. Okay? So remember, the c's cancel out, so I went ahead and got rid of my c's. And so now what we have is a negative 2e to the basically negative 1.5 plus, right? If I distribute my negative, that becomes a plus 2 times, well, e to the 0 power, because 0 times a negative 0.5 is 0. E to the 0 power is 1. So that just becomes a 1. All right? And so then the final answer is a negative 2e to the negative 1.5 plus 2. And if you wanted to see what that is as a decimal, let's see, negative 2 e to the negative 1.5 plus 2. And there you go. All right? Okay, so that's how you perform, that's how you integrate e. Okay, we're going to have to do this u substitution. And what I want to highlight really quickly, folks, is that the correcting factor, the thing that we have to multiply our du equation by to get it to match up correctly, is this 1 over the coefficient of the power. Okay, so just keep that in mind. All right, so now, with that being said, now we can talk about income streams. So as I said, an income stream, as the name implies, is not just one deposit that you make, it's several deposits that you make. And you want to know, sometimes you want to know, okay, what's my future value and what's my present value of these income streams? All right. Well, it turns out that the future value, so this is shorthand notation for future value of an income stream, is the following. It's the integral from 0 to some time t of your income stream, okay, times e to the positive rt dt. Okay. And so if you've had calculus before, you've seen like a slightly different formula for this. I'm giving you the computational formula that's going to quickly give us to our answer. But yes, as you read other math books, you'll see a slightly different formula, but we're going to end up at the same place. All right, so what are the values in this formula here? So f of t is your income stream. For us, our income stream is not going to be variable. It's not going to change. It's just going to be a constant. Okay. R is your interest rate because we're taking this income stream and we're investing it. And then T, capital T, is the number of years in which you'll be performing this investment. Okay. So those are all the pieces to this future value income stream question. Let's see if I got a problem here. All right. For example, suppose you invest a continuous income stream of $6,000 per year at a rate of 4.25%. What will be the value of this continuous stream after 10 years? Okay, so I know this is the first example we're doing here, but the first thing you need to do when you're trying to figure out is this a future value or present value is that you have to really understand the context because there's going to be both future value and present value questions in this homework. So future value means I'm trying to figure out how much that money is worth, well, in the future. Present value means I need to know how much that future money is worth to me in today's dollars. Okay. All right, but this is a future value question because I want to know what is the value of this stream 10 years from now. So I'm just going to rewrite the formula for your convenience. Remember, our future value formula for an income stream is the integral from 0 to t of our income stream times e to the positive rt dt. Okay, so what does that look like for us? Well, we're going to integrate this function from 0 to capital T means how many years are you investing this money? We're going to do it for 10 years. And f of t is your income stream. What is our income stream? Well, it's the constant $6,000 times e raised to our interest rate times the variable t. Our interest rate is 4.25%. You must write that as a decimal. Okay? So it's going to be 0.0425 times t dt. All right? So that is our integral set up. And now we're going to solve this via u substitution, just like we did in the very first example here. So we're going to let u equal the power on e, the exponent on e. So u equals a 0.0425t, which means du is equal to a 0.0425 dt. All right? But if you look at our integral, instead what we have is a 6,000 dt. Okay, we don't have a 0.0425 dt. So what's our trick? Okay, the trick is to multiply both sides of the du equation by the value in your integral for your differential. So we're going to take 6,000 and divide it by a 0.0425 du. That's what equals a 6,000 dt. Okay. Sorry for my handwriting. Just to be clear here, why does that reduce to a 6,000 dt? Because what you do is you take the 6,000 divided by the 0.0425, and then that multiplies the 0.0425 dt. That's already there. Goodness gracious. Okay. 0.0425, there should be a decimal point there, dt, and the 0.0425s cancel out, and that's why you're left with the 6,000 dt. Okay? All right, so let's perform that substitution in our integral. So let me get a different color here. So our integral, I'm going to drop my bounds right now because I'm about to switch over to u's. 0 to 10 is in terms of t, but we're about to be in terms of u. We're going to have e to the u, and then the 6,000 dt actually is a 6,000 over a 0.04, let me give myself some more room here, 0.0425 du. Okay? All right. As we integrate, we know that we're going to get 6,000 over 0.0425 times e to the u. All right? Because the integral of e to the u is the same thing, e to the u. All right? And then now I need to rewrite u in terms of t. And if you remember, u is a 0.0425t. So my integral, my antiderivative is a 6,000 over 0.0425 e to the 0.0425t. And remember, it's a definite integral. We have to evaluate this from t equals 0 to t equals 10. Okay. All right. Here we go. So to do this, we need to plug in t for 10. But what I'm going to do here to kind of make our calculation a little easier, this 6,000 over 0.0425, that's a constant multiple, and I can pull that out. So what I'm going to do is I'm going to do this. We're going to have 6,000 over 0.0425 times, and then now I'm just going to plug in my 10 in for t. It's going to be e to the 0.0425 times 10, right? Minus e to the 0.0425. Now it's going to be multiplied by 1. Okay? So once again, I can pull out that 6,000 over 0.0425. All right. And so quickly before I jump into the calculator, we can actually reduce this a little bit. Okay? So the e to the 0.0425 times 10, we'll calculate that in a second. But for the second term here, 0.0425 times, that should be 0. Where I get 1 from? It should be times 0. And then anything raised to the 0 power is 1. So that second term will become 1. And in fact, for all of these future value and present value questions, we always start with times 0. So that second term will always become a 1. Okay, so now to figure this answer out to 2 decimal places, we're going to go to our calculator. Let's make this a little bigger. All right. And so what we're going to do is, I'm going to do open parentheses. I'm going to do my 6,000, right? Let me share 6,000 divided by 0.0425. Okay, I'm going to close parentheses. Then I'm going to open up another set of parentheses because we're going to multiply that by, now we're going to bring in the e stuff. So second ln, e to the 0.0425. This is multiplied by 10. I need to come down and then subtract away 1. Okay, make sure you use your parentheses carefully. All right, hit enter. And there we go. We get 74,765 and 71 cents. Okay. So if we invest that $6,000 every year for 10 years continuously, we're going to have 74,765 and 71 cents in the bank. So that's how you handle future value. All right. Present value, on the other hand, it's a slightly different formula. Present value, so what if we want to know the present value of an income stream? Well, it's the integral from 0 to t of, once again, our income stream times e to the negative rt, dt. Okay? Really quickly, where does the negative and the positive comes from? It comes from this fact right here. Future value of an investment that's continuously compounded is the present value times e to the rt, right? So that's why when we did the future value, we had a positive rt. But what if I wanted to solve for present value? Well, that means I need to divide both sides of this equation by e to the rt. So I have future value divided by e to the rt. And we know that if we wanted to rewrite this fraction by bringing up that numerator, we know we take the denominator, we take the opposite sign. So that's why present value is future value times e to the negative rt. All right. So at the end of the day is this, folks. If you're finding a future value question, it's e to the positive rt. If you're trying to find a present value, it's going to be e to the negative rt. That's the difference. But the way you integrate is going to be exactly the same. We're going to do u substitution. Okay? Here we go. Let's see. For example, suppose a restaurant is looking to upgrade. The new equipment costs $40,000, but they predict it will result in an additional $10,000 in sales each year. So it's going to bring in an income stream of $10,000 a year. The question becomes, should they update the system? That's a typo. Should they update the system and put the additional income into an account yielding 2.5% interest for 5 years, or should they not update and just take that $40,000 and invest that? Okay? So the question becomes, should I buy this equipment today for $40,000 based off of how much money it's going to give me in the future, or should I not? Okay? So this actually becomes a present value question. All right? Why is that? It's because this money that I'm going to get from this new equipment, it's going to pay me out in the future. So what I need to know is I need to know how much is that future money worth for me today. Let's say we do the math and we find out that that future money is only worth $30,000 for me today. Well, I'm paying $40,000. It's only going to generate $30,000 in the future for me, so I shouldn't do that. But if this machine is going to generate more income, more than $40,000 for me, then absolutely I should invest in it. Okay? So let's see. So this is a present value question, and so here we go. So we know that the present value is the integral from 0 to t of our income stream times e to the negative rt. We call this discounting, is where the negative comes from, because you're going back. All right, so here we go. So we're going to integrate this from 0 to how many years are we going to invest our additional income? We're going to invest it for 5 years. So the integral goes from 0 to 5 of our income stream. The income stream will be the $10,000 times e to our interest rate, negative interest rate. Our interest rate is 2.5%. Write it as a decimal. So it's a 0.025 times t dt. All right. Got to do u substitution. So we know u is a negative 0.025t, which means that du has to be a negative 0.025 dt, but we don't have that. We know the trick. The trick is we need to multiply the du equation by a 1,000 divided by the negative 0.025. Be careful with your negatives there. So if I multiply that fraction on the right side of my equation, the negative 0.025s cancel, and we're left with the 1,000, excuse me, the 10,000. 10,000 dt. Okay, now let's substitute. We're going to drop our bounds because we're about to switch over to u's. So we're going to have e to the u. And then the 10,000 dt, we just said that's a 10,000 over a negative 0.025 du. All right. Then we integrate, and we know that, oh, the integral of e to the u is the same thing, e to the u. So this becomes, after we integrate, we get 10,000 over negative 0.025 times e to the u. And then we bring back our t. So u was a negative 0.025 t. Okay, and we evaluate this from t equals 0 to t equals 5 years. We're going to do the same kind of trick we did before. Is I'm going to factor out that 10,000 over negative 0.025. And then that's going to multiply e, negative 0.025 times 5 minus e to the negative 0.025 times 0. And that second term in our brackets, we know that that becomes just 1 because e to the 0 power is 1. All right. Lastly, we go to the calculator. Here we go. So it's going to be 10,000. Oh, let me put that in parentheses. So let's do parentheses 10,000 divided by, what was it, negative, I'll make sure I actually type my negative. Let's do negative 0.025. Okay, and then open up another set of parentheses, and it was e to the negative, make sure your negative's at the bottom of the calculator, 0.025, and it was times 5 minus uno. Close that up, hit enter. There we go. We get 47,001 and 24 cents. So 47,001.24. Okay, so what does this mean? This means that the money that we're going to earn in the future is worth to us today $47,000. $47,001.24. So because of that, we should purchase the equipment, all right? Because the present value of the income stream is more than the cost of the machine. Okay? And remember, the cost was $40,000. So what we just found is that if we spend $40,000 today, we're going to end up with $47,000 down the line, but in today's dollars, if that makes sense. So absolutely, we should purchase this equipment because the present value is more than the cost. Once again, let's say that our answer was $37,000. In that case, I do not want to purchase that equipment because the present value of my money that I'm going to earn later on is only worth $37,000, but I'm paying you $40,000 today. All right. I know it's a little confusing, but hopefully that'll kind of get you set on the right path. I'll see you guys in our next video.